Welcome to Spread the Word Understanding Measures of Dispersion. Hey, welcome back. I'm Alex, and today we're diving into something that I think is genuinely underrated in statistics. Measures of dispersion. Now you've probably already heard about mean, median, and mode, the measures of center. But here's the thing. Knowing the center of your data only tells you half the story. Today we're talking about the other half, how spread out your data actually is. We're covering 4 key measures: range, IQR, variance, and standard deviation. Let's get into it. Alright, let's start with the simplest one. The range. The formula couldn't be easier. It's just maximum minus minimum. That's it. You take the biggest value in your dataset, subtract the smallest, and boom, you've got your range. It tells you the total width of your data. Simple, fast, done. But here's the catch. The range is extremely sensitive to outliers. Like one single weird data point can completely blow it up. Imagine your class got these test scores 50, 60, 65, 70, 72. The range is 22. Pretty reasonable. But now imagine one student scored a 98. Suddenly your range jumps to 48. Same class. One extra score. Totally different picture. That's the problem. The range reacts dramatically to extremes, which means it can be really misleading. So we need something better. And that's where the issue comes in. The interquartile range. The formula is Q3 minus Q1. Now what does that mean? Well, if you line up all your data from smallest to largest and split it into 4 equal parts called quartiles, Q1 is the value at the 25th percentile and Q3 is the value at the 75th percentile. The IQR is the distance between those 2 points. In other words, it captures the middle 50% of your data. Think of it like this. You're ignoring the top quarter and the bottom quarter, the extremes, and just measuring the spread of everyone in the middle. That's why the IQR is described as highly robust to outliers. That one student with the 98 gone doesn't affect the IQR at all. This makes it a much more stable and reliable measure of spread, especially when your data has extreme values. Remember that outlier problem we just talked about with the range? The IQR basically solves it. Quick break. We'll be right back. Today's episode is brought to you by Bessel's correction. Because your sample data has been lowballing you this whole time. Divide by n-1. You deserve the truth. Alright, back to learning. Okay, now let's step it up a little. Let's talk about variance. Variance is defined as the average squared deviation from the mean. Let me break that down. First you find the mean of your dataset. Then for every single data point you calculate how far it is from that mean. That's the deviation. Then you square each of those deviations, then you average them all up. That's your variance. But why do we square the deviations? Great question. Because if you just average the raw deviations, the positive and negative distances, they'd cancel each other out and you'd get 0 every time. Squaring them keeps everything positive and actually amplifies larger deviations, which is useful. Now, and this is important, there are 2 versions of variance and you need to know the difference. Population variance is when you have data for an entire population. You divide by n the total number of data points. Sample variance is when you're working with a subset of a larger population, which is most of the time in real life. Here you divide by n-1 instead. This adjustment has a name: Bessel's correction. Here's the intuition. When you take a sample, you tend to underestimate how spread out the full population really is. Dividing by n-1 instead of n compensates for that bias and gives you a more accurate estimate. One more thing about variance. It's measured in squared units. So if your original data is in meters, your variance is in meters squared, which is a little awkward to interpret. And that brings us to our final measure: standard deviation. This one is the most widely used measure of spread in all of statistics. And for good reason. The formula is simple. It's just the square root of variance. That's it. You take your variance and square root it. But why does that matter so much? Because taking the square root brings you back to the original units of your data. Remember, variance was in squared units, which is hard to make sense of. Standard deviation fixes that. If your data is in meters, your standard deviation is in meters. Same units as the raw data. That makes it directly interpretable and incredibly practical. You can say something like the average score was 70 with a standard deviation of 5 points. And that actually means something. A small standard deviation means your data points are clustered tightly around the mean. A large standard deviation means they're spread out all over the place. Just like variance, standard deviation comes in two flavors: population and sample. Depending on whether you divide by n or n-1 before taking the square root. So let's bring it all together. We covered 4 measures of dispersion today. Range is the quickest and simplest. Max minus min. But watch out, one outlier can throw it completely off. It solves that problem by focusing on the middle 50% of the data, making it robust and reliable. Variance captures the average squared deviation from the mean. Just remember to use n for a population and n-1. Thanks to Bessel's correction for a sample, and standard deviation is the square root of variance. The most interpretable of the bunch because it speaks the same language as your original data. Together, these 4 tools give you a complete picture of how spread out any dataset really is. And in statistics, spread matters just as.
Well, the range walked in, looking all covered and tall. Max minus min, baby, that's no math at all. One strange number slid in through the door. Now your range is a lie, it don't mean nothing no more. So I called up IQR, that cool and steady friend. Q3 minus Q1 from the middle to the end. Middle 50%, let the outliers roam. Better robust little number, it don't bring them home. Oh, it's the best of blues. Your sample's been lying, paying all the wrong dues. Divide by n-1, let the truth come through. Cause your spread was too small and that just won't do. Variance squares the distance so it never hits 0. Average in on out, now you're the squared unit hero.